different types of onto functions. We have seen that what is meant by onto, and we have listed the different type of examples which are onto, which are not onto. Right. Now, counting principle for finite sets. Suppose cardinal of A is M, cardinal of B is N. So number of onto functions. From A to B. Right. There are again two cases. If M is less than N, suppose you take this example. Suppose A, B, 1, 2, 3. So cardinal of A is 2, cardinal of B is 3. So therefore 2 is less than 3. The thing is, can we find an onto function? Can you find an onto function? So not possibly, right? So therefore, whenever M is less than N, 0 onto functions. Right? Whenever M is bigger than or equals to N, so there is a formula for that. Total functions minus summation R equals to 1 to N NCR N minus R whole power M into minus 1 whole power R. We need to write like minus 1 whole power R. You need to first write minus 1 whole power R. So this is the formula for that. Number of onto functions for finite sets only. This is not applicable for infinite sets. Suppose this is a question appeared in CSIR. Number of onto functions from A to B, where cardinal of A is 4 and cardinal of B is 3. This question appeared in CSIR. Yeah. So here, just look at this. What is the coordinate of A? This is here. M is equals to 4, N is equals to 3. Therefore, we observe that M is always bigger than N. Therefore, number of onto functions is possible. Number of onto functions is possible. There exists an onto functions from A to B because M is bigger than N. M is bigger than N. Therefore, number of onto functions from A to B is, so total functions. What is total functions? 3 power 4. That means what is the formula? You need to write it first. NC n power m plus r equals to 1 to n minus 1 whole power r NCR n minus r whole power m. This is a formula. So what you do? Just apply the formula. 3 power 4. See, alternates changing the sign. That's it. So this is minus. What is my n? 3. So 3C1. 3 minus 1 whole power 4. Alternate, change the sign. 3C2. 3 minus 2 whole power 4 minus 3C3. 3 minus 3 whole power 4. That's it. You need to change alternate sign. Right? What is 3 power 4? 81. This is 3 into 16. 3C2 is nothing but 3. 1 power 4 is 1. This is 3 minus 3 is 0. Right? So 81 minus 48 plus 3. Right? So 84 minus 48. 84 minus 48. What is this? 6. So 36. So number of onto functions from A to B is total 36. Total 36. no need to remember this formula. What you do is just total functions minus just receive 1, 3 minus 1 whole power n. Just changing the alternate signs. Keep doing on until you're going to get 0. Until you're going to get 0. Right? So can you write 1 functions from A to B? It's not possible, right? Here 3 is bigger than 4. Therefore, number of 1 function is not possible. So there is a notice. If cardinality of A bigger than or equals to cardinality of B, definitely there exists an onto function. See, we have seen actually whenever cardinality of A less than or equals to cardinality of B, definitely we can find a 1 function from A to B. Whenever the cardinality of A bigger than or equals to cardinality of B, this is obviously possible by graph. See, this contains more elements. This contains more elements. So automatically onto function is possible, right? Next is bijection. So a function from A to B is to be bijection if and only if just it's 1 as well as onto. If the function from A to B is 1 as well as onto, 1 as well as onto. So 1 means what you observe? Already told you cardinality of A less than or equals to cardinality of B. Onto means cardinality of B less than or equals to cardinality of A. So A modulus of cardinality of A less than or equals to B and cardinality of B less than or equals to. Therefore, cardinality of A must be equals to cardinality of A. So whenever f is a bijection from A to B, so we observe that cardinality of A equals to cardinality of B. This is 1, 2, 3. Suppose you take ABC. Right? This is it bijection? Yes, because it is 1 as well as onto. So there is no free element in B, and every element, distinct elements of A, have distinct images in B under the function F. Therefore, it is 1 function. Now, suppose you take second example. Suppose 1, 2, 3 is ABC. Is it bijection? Is it bijection? The answer is no. The answer is no. Right? Because C is a free element. For C has no preimage. In A under F. Therefore, it's not onto. It fails to be onto. Right? So what you observe generally, notice is what you observe in order to define a bijection function. First, the cardinality of A must be equals to cardinality of A. See, converse may not be true. If the cardinality of A, look at this problem. If the cardinality of A equals to cardinality of B, that need not imply that F is a bijection. If F is a bijection, cardinality of A equals to cardinality of B. Obviously, this is true. That doesn't mean that if the cardinality of A equals to cardinality of B, that means if F need not be a bijection function. This is an example. Right? We'll see later. Cardinality of R is actually continuum. Here cardinality of R is continuum. Therefore, these two continuums are same. Therefore, this cardinalities both are same because both are equal sets. But the thing is, it fails to be 1 function. Of course, not onto function also. Therefore, it is not bijection. You have seen actually, it's not bijection function. Y equals to x square. It's not my bijection. So therefore, if the cardinalities of both sets are equal, that doesn't mean that the function is bijection function. But one can say that if cardinality of this is note actually. These are very, very important notes. Already I told you, because I'm going to use these ideas in next countable concepts. If the cardinality of A equals to cardinality of B, definitely there exists a bijection function. There exists a bijection function from A to B. Understand? There exists a bijection function. So if the coordinate of A equals to coordinate of B, definitely we can find a continuous function, right? For example, we have seen actually last example. Suppose you take this identity function. So here the coordinate of A equals to coordinate of B. Of course, it is a bijection if it's defined by identity map. So it's a line passing through origin, right? Therefore, what? Therefore, it is one function, right? By drawing a line parallel to x-axis, it meets exactly 1 point. Therefore, it is 1. Is it onto? Obviously, because any line drawn parallel to x-axis, automatically it meets the given curve at least 1 point. At least 1 point. Any line that you draw parallel to x-axis, definitely it meets the curve at least 1 point. At least 1 point. Therefore, it is an onto function. So hence it is bijection. Hence it is bijection function. Right? Suppose we take this. F is a function from R to R defined by fx is equals to x square. We have seen actually it's not bijection. We take x cube. Is it bijection?
Yes, sir.
Yes, it's bijection. Right? We have seen actually these concepts. So by drawing a line parallel to x-axis, definitely it meets exactly 1 point and at least 1 point. Therefore, it is both 1 and 1 Once both 1 and 1 automatically it is a bijection map. So can you give me onto function which is not 1 function? Can you give me onto function which is not 1 function? So give an example.
F from R to close 0, infinity.
Function from A to B, which is 1, of course, which is 1, but not 1, 2.
Same function. Domain is the closed interval to 0 to infinity, sir.
Yeah, same function. This one, no? So therefore, what is this? So it's clearly 1 function. There is no problem. This is my 0. This is 1. So therefore, this is my actually curve. Right? The thing is, see, sorry, my codomain is what actually. This is wrong, bro. My domain is what? Total R. My codomain is what? 0 to 1 itself. So therefore, what you get? Right? So therefore, what you observe? It is 1 function. It is 1 function. Is it onto function? Suppose you take a negative element. Y equals to -1. Does it have every image? No image. Therefore,
Yes,
it cannot be onto function. 1, but not onto.
Sir, 1 ఎలా అవుతుంది సార్ అది?
There is no problem, right? 1 problem ఉందా ఏమన్నా?
అంటే ఇందులో 3 R లో డొమైన్ లో 3 తీసుకుంటే 8 9 27 అవుతుంది కదా సార్? 27 కోడ్ డొమైన్ లేదు కదా?
You actually it is not a function, sorry.
Function, not a function.
It's not a function, sorry. It's not a function. It's not a function because my domain is total R. My domain is what? Total R. Good.
Stick the domain.
The thing is actually we are working with real numbers, not a closed and bounded interval 0 to 1. So my domain is what actually? My total real numbers are. My total real numbers are. Therefore, when you take a different element, x is equals to 2, it has no image. It has no image. Therefore, not a function in fact. ఇది పనిచేయదు కదండి.
Sir, f r to r f of x is equal to x square is 1 but not onto.
Yeah. మీ ఇష్టం ఏదైనా ఒకటి తీసుకోండి. 1 1 కావాలి బట్ ఆన్ 2 కావద్దు. therefore we can take
0 to plus infinity.
fx is equals to x square, right? So therefore what is this? This image 0, it going on, therefore drawing a line, definitely it meets the given curve exactly 1 point, therefore it is 1 1. So clearly not onto by taking a line, negative line. So but not onto, there is no preimage, right? So now give me an example. Give an example of onto function but not 1 1. See,
Sir, same function, sir. Domain R.
domain R,
Codomain is closer 0 to infinity.
domain R,
Codomain closer 0 to infinity.
same function.
Same function.
Yeah, is it 1 1 function? No,
No,
right?
sir.
Is it 1 1 function? No, right?
No.
So therefore suppose you take -1 and +1, it has image 1 but 1 not equals to -1. So therefore automatically is not function, is not 1 1 function. So question is it onto function?
Yes, sir.
Is it onto function?
Yes, sir.
So clearly you take any element, you need to do it. You take any element in a codomain, definitely any positive real number, we can have a unique real number. We can find a unique real number in such a way that x power 2 or x power n is equals to y. This is obviously possible, right? There exists a unique x in such a way that in fact actually what is the preimage for y? Anybody? What is the preimage for y?
Root x.
Root x. So therefore what? Root x whole square, therefore what? This is what actually x, because we are working with only non-native real numbers. We are, see, what is my x actually? Anybody? Root y, right? Root y, not x, because x is not meaningful now. You are finding a y which is non-negative, y which is non-negative, yes or no? Y which is non-native real numbers. So therefore it is meaningful, it makes sense. This is a real number. Whenever y is non-native real number, root y is makes sense. Otherwise it is not defined. Therefore what you get? You're going to get this. So this is my x actually. X is equals to root y is my preimage. X is equals to root y is my preimage. Now my suppose you take a function if x is equals to like a signal function. Is it bijection?
No, sir. It's not 1 1.
No, sir.
So right, so x
Different
positive you are going to get
images.
1, x negative you're going to get -1. Therefore is it 1 1 function first of all? No, right? By drawing a line x y equals to 1, it meets infinitely many points. By drawing a line y equals to 1, it meets at infinitely many points, not 1 1. Not 1 1 means automatically not bijection. Not bijection, right? Suppose you take another example. Yeah. Is it bijection?
Bijection, sir. Bijection.
Yes. Sir.
Yes.
Check the answer once again. Look at the question. First of all, is it 1 1 or question 1 1 or not? If you take any two elements, in such a way that fx equals to f5, that means ax plus b equals to ay plus b. So addition, we are working with real numbers, therefore automatically it is a group.
X is
Ax
equal to
equals
y.
to, not x equals to y, not, don't tell like that. Either a0 or x minus y equals 0, because you are working with the field real integral domain, therefore it has zero divisor. It has no zero divisors, either a0 or x minus y0. If a0, the function could be a constant function. Substitute here. If a0, 0 into x is 0 into x plus b, that is b. This is true for every x. So your function is a constant function. Therefore, it cannot be 1 1 function. It cannot be 1 1 function. So whenever a is 0, we're not getting a 1 1 function. So or else, if a is non-zero, suppose you take a is non-zero. A is non-zero means what? X minus y equals 0 or x equals to y. So this is 1 1 function. What do you observe? This is 1 1 function if a is non-zero. Understand? If what do you observe? It is 1 1 function if a is non-zero. The thing is it onto function? If a is non-zero, is it onto function? If a is
Yes,
non-zero, definitely it is looking like the slope like this. It is like this or negative slope. Understand? So definitely, suppose you take a, it is a positive slope. Suppose a line which has a positive slope. Without loss of generality, assume that a line which has a positive slope. So therefore, what you observe, any line draw parallel to x-axis, definitely it meets exactly 1 point. So at least 1 point. Therefore, it is both 1 1 and as well as onto function. If a is non-zero, remember a is non-zero, right? If a equals 0, is it onto function? No, because it's a constant function.
Prasad sir.
Hello.
Hello, excuse me, Prasad sir.
Oh.
సార్ ఇక్కడ స్టార్టింగ్ లో మీరు ఏవై తీసుకున్నారు కదా సార్.
మీ వాయిస్ ఫ్లక్చుయేట్ అవుతుంది మేడం. హలో
సార్ ఇక్కడ ఇన్స్టెడ్ ఆఫ్ యూ హ్యావ్ టేకెన్ ax is equals to ay na sir, and again in the second step you have taken a into x minus y equal to 0. So taking a into x minus y directly, if we cancel both a and a, we get x is equals to y, then it becomes 1 1 function na sir. Instead of doing that much, I feel.
Don't cancel a, right? If you take a equals to 0, does it cancel?
No sir.
How can you cancel a equals 0? How can you conclude that a is non-zero? If a is non-zero, we can cancel them. Understand? If you take 0 0 0 by 0, can you cancel?
No.
So how can you conclude that a is non-zero? By doing the problem, by looking at the problem. If you conclude that a is non-zero, definitely x minus y equals to 0. If so, there are.
Yes, sir.
Take this.
Yes, sir.
If x is equals
Yes,
to a.
sir. Yes, it is on to sir.
Is it onto?
Yes.
Is it onto? Write in chat box.
ఏ నాన్ జీరో అయినప్పుడు అవుతుంది సార్ ఆన్ టు ఫంక్షన్.
Use chat box. Use chat box. Yeah, Naresh Kumar. Yes, it's onto a whenever a is non-zero. Okay, that's right. Right. So we have seen actually. So just take a codomain element. I don't know whether it is onto or not. Take a codomain element. First, you need to guess it. If suppose there exists a pre-image for the y element, right? This is my domain. This is my codomain. Suppose you take an element here. So for loss of generality, we can have a pre-image. We don't know whether it does exist or not. I don't know. Suppose I can have a pre-image under the function f. So what happens? Ax plus b is equals to y. If such a x is possible, definitely we can have a pre-image for every y. So we need to solve the equation for x. Because what I'm interested in only x for finding x, whether the x exists or not in R. So look at this. What is my x? Y minus b. So therefore x is equals to y minus b divided by a. It's possible if a is non-zero, because this could be a real number. This could be a real number if a is non-zero. Therefore, it is an onto function. It is an onto function if a is non-zero. Right? If a is zero, we can have we don't have any pre-image for the same y. We don't have a pre-image for the y, because if it's not a real number, x is not a real number. Y minus 0 by 0, y minus b by 0, it's not a real number. Right? For this y, we don't have a pre-image. Whenever a is 0. If a is non-zero, this is my pre-image. Therefore, it is an onto function for a non-zero. Right?
Sorry, excuse me, sir. Instead of analytically, f of x equal to ax plus b means it's a slope intercept form, sir.
Slope intercept
line.
form. Y equals mx plus a.
Y equal to mx plus c. So we can extend either sides of the line, then we cannot find the line which is parallel to x-axis not meeting the corresponding.
లైన్ అనేది నేను ఇక్కడ ఫిక్స్డ్ రియల్ నెంబర్ ఇవ్వలేదు. నేను ఇక్కడ యాక్చువల్ గా మీరు డిపెండ్ స్లోప్ ఇంటర్సెప్ట్ ఫామే. థింగ్ ఏంటంటే ఇక్కడ ఏ అనేది వేరే ఫిక్స్డ్ రియల్ నెంబర్ కాదు. ఫిక్స్డ్ రియల్ నెంబర్ కాదు. ఏ ఇక్కడ ఆర్బిటరీ వేరే అవుతుంది. ఓకే, ఏ మీద డిపెండ్ అయి ఉంటుంది లైన్. ఓకే, ఇఫ్ ఏ 0 అయింది అనుకోండి కాన్స్టెంట్ ఫంక్షన్ అవుతుంది.
అవును సార్.
ఓకే, ఇఫ్ ఏ 0 అయింది అనుకో ఏమైంది?
అదే నాన్ జీరోకి అయితే అది స్లోప్ ఇంటర్సెప్ట్ ఫామ్ అవుతుంది కదా సార్.
నాన్ జీరోకి లైన్ అయితే డెఫినెట్ గా వీ కెన్ హ్యావ్ ప్రీ ఇమేజ్. ప్రాబ్లం ఉండదు.
ఓకే సార్,
ప్రాబ్లం ఉండదు. ఏ 0 అయినప్పుడు మాత్రం కాన్స్టెంట్ ఫంక్షన్ అవుతుంది. అప్పుడు డెఫినెట్ గా ఆంటో ఫంక్షన్ కాదు.
ఓకే.
సో నేను ఇది అనలిటిక్ మెథడ్ ఎందుకు చూస్ చేసుకున్నాను అర్థమైంది ఇప్పుడు మీకు ఎవరికైనా? అనలిటిక్ మెథడ్ ఎందుకు చూస్ చేశాను అంటే, గ్రాఫికల్ మెథడ్ ఇక్కడ యాక్చువల్ గా డైరెక్ట్ ఇదేంది లైన్ కాబట్టి చూడడానికి లైన్ కాబట్టి, ఇదేంది స్లోప్ కాబట్టి డెఫినెట్ గా మీట్ అవుతుంది కాబట్టి 1 అవుతుంది, ఆన్ 2 అవుతుంది అని పొరపాటున కనుక మీరు ఆన్సర్ లో పెట్టారనుకోండి, ఆన్సర్ రాంగ్. కాబట్టి ఇక్కడ డిపెండ్స్ అపాన్ వాల్యూస్ ఆఫ్ ఏ మీద డిపెండ్ అవుతుంది కాబట్టి కొంచెం జాగ్రత్త చేయాలి. ఎక్కడ అనలిటిక్ వాడాలి, ఎక్కడ గ్రాఫికల్. సో కొంచెం కేర్ఫుల్ ఉండాలి. ఓకే, రెండు వస్తే మంచిది. Right. So with this, take another problem. Suppose take sin mod x. Is it bijection? We have seen already told you, whenever x is mod x is there in place of x, what you do is that right side curve is as it is. This is my sine. What is my sine curve? This is my sine curve. So right side curve we need to as it is. You need to write as it is. So left side is what? Actually just reflection image of this with respect to y-axis. Therefore, it's not 1 1, not onto, because it has no image. Suppose you take more than this is what is my y equals to 1. You can take 1.1. Y equals to 1.1 because the maximum value is 1. You take any line bigger than 1. నేను 1.1 తీసుకున్నాను. 1.1 కి ప్రీ ఇమేజ్ ఉండదు. Therefore, it is not onto. Of course, it is not 1 1. Right. So therefore, this is my sine function. Right. So what I told you that above x-axis keep it as it is, because the mod sin x is there. So above x-axis keep it as it is. Next, what you do for the negative, this below x-axis graph, just right above this curves, above x-axis. Therefore, it's not 1 function. Similarly, not onto function because there is no preimage for 1.212. So therefore, it is not 1 as well as not onto. So therefore, bijection. This is what actually things of bijections. Now we need to go for counting principles. Suppose cardinality of A is M. See what I told you, the cardinality, whenever you want to define a bijection, cardinality should be same. Just keep in mind, already I told you. So then the number of bijections from A to B is equals to, so already I told you, if M not equals to N, 0. We have seen already, right? If M not equals to N, it is 0. If N equals to N, look at the possibilities. So means A and B both have the same cardinality. AN, B1, B2, BN. So for 1 is what I require, actually I require to have bijection function. For A1, how many choices? N choices. How many choices? N choices. For A2, already A1 is fixed. A1 is, suppose you assume that A1 is fixed by B1. How many choices for B1? A2? How many choices for A2?
N minus
N
1.
minus 1 choices. Going on, already told you what is this? 1 choices. Therefore, N into total. So the work is completed. The work is completed. Therefore, total formula is what? Total number of bijections is nothing but what? N into N minus 1 into 3 into 2 into 1. This means what? N factorial. That means what? N factor. So this is what counting difference. This is very, very important. So these questions are important. This question asked in CSIR, right? ఇంతకుముందు problem actually ఎట్లా అడిగాడు అంటే the coordinate of A is 4. If coordinate of B is 3, then the number of 1 functions from A to B is number of onto functions from A to B, number of bijections from A to B, number of not onto functions, not one function. This is what? Many one function in some books. Many one functions is the one gani. Number of into functions, not onto functions, that is we call it as into functions. Not onto functions. In some books, we call it as into functions. Is number of relations. Number of relations from A to B. Right? Number of functions okay, this type of question asked in CSIR recent papers. So what is this actually? Your 1 functions cannot be possible, right? 0. Because why? Because 4 is bigger than 3. Number of onto functions, we have seen this answer. What is this? 36. It's possible, right? Why? Because 4 is bigger than 3. Number of bijection functions? 0. Because 1 fails. 1 fails means what? It's not bijection. Number of many one functions means not 1 functions. Total functions minus 1 functions. Total functions minus 1. I'm interested in finding not 1 functions. So total minus 1. What is total? Total functions. What is total functions? 3, 4, 4 minus 1 functions. Understand? 1 function is 0. Therefore 3 power 4. Right? 81. Right? Number of onto functions. Number of not onto function means into functions. Not onto means we call it as into. Yeah. So what is it? Total functions minus onto functions.
46.
So total means
45.
3 power 4. Income 81 minus 36. What is this? So 7 minus 3, 45. Okay. Number of relations.
2 power 12.
2 power 3 into 4. 2 power 3 into 4 means 2 power 3 into 4 means 12. Number of functions from A to B. Number of functions from A to B. 3 power 4, 81. Number of relations, not functions, which are not functions. Relations from A to B, which are not functions. So what is this? Total relations minus functions. Mana కావాల్సింది function కానీ total minus not functions రావాలి. Not function అంటే total minus functions. Functions ఎన్ని? 3 power 4. Right? Next is some properties. First one, if f is a bijection from A to B, so these are very, very important when you are working with linear algebra, vector space. So when you are given a bijection function, definitely what is meant by bijection? Definitely inverse also bijection function, then whose inverse also bijection, right? And also such that, so whenever it is bijection, inverse also bijection, so this is my inverse, so their composition is meaningful. This diagram commutes. So what is this? F inverse F circle, F inverse circle F is equals to identity map on A. Similarly, so this is my bijection function. Of course, inverse is, what is my inverse? Inverse is bijection function, right? What is this? The composition. This composition is meaningful whenever diagram comments. Therefore, F circle F inverse. What is this? This is an identity function on B. These are standard results which are in functions. Right? Next is, suppose if you are given a function, just a function is a function. This is important in linear algebra. This is a function from A to B. Definitely, this is my function from A to B. Definitely, we can find then identity function from B to B. This is IB. So that means what? F circle. This means IB circle. Means what is meant by IB? IB is nothing but what? Identity function on B. Circle F is equals to F. Similarly, what is this? This is my identity function on A. So therefore diagram comments. So F circle IA. So F circle IA is nothing but what? Is nothing but F. So therefore what you observe is any function, definitely we can have an identity element. This is nothing but identity function on B as well as the identity function on A. So therefore this is always possible.
సార్ ఒక్కసారి డయాగ్రామ్ అది ఎలా వచ్చిందో ఒక్కసారి చెప్పరా సార్?
See, ఒక ఫంక్షన్ మీరు కనుక తీసుకున్నారు అనుకోండి, ఇట్లా రైట్. ఈ ఫంక్షన్ తీసుకున్నారనుకోండి, నేనేం చేస్తున్నానంటే జస్ట్ ఐడెంటిటీ ఫంక్షన్ తీసుకుంటున్నా. బి టు బి. సో ఏ టు బి ఫంక్షన్ ఉంది, బి టు బి ఫంక్షన్ ఐడెంటిటీ ఫంక్షన్. సో కాంపోజిషన్ రూల్ ప్రకారం డెఫినెట్‌గా ఏ టు బి ఫంక్షన్ ఎగ్జిస్ట్ అయితది కదా! ఇదైతే తెలుసు కదండీ. కాంపోజిషన్ ఫంక్షన్ ఫ్రమ్ ఏ టు బి. ఇదే నేను ఇక్కడ రాశాను. కాంపోజిషన్ ఫంక్షన్ ఏంటి మళ్ళీ? అగైన్ ఇట్స్ ఎ ఫంక్షన్ ఫ్రమ్ ఏ టు బినే. అంటే ఏంటి? ఫంక్షన్ ఎఫ్ఏ. స్టాండర్డ్ థీరమ్స్ ఇన్ ఎనీ if you take any function textbook, definitely we can have a result. So this is my function from A to B. F is my function from A to B. B and ఈ IB అంటే ఐడెంటిటీ ఫంక్షన్ ఆన్ B. ఈ రెండింటి కాంపోజిషన్ చేస్తే మళ్ళీ FA వస్తది. అది రిజల్ట్. రైట్. Fని IA తోని కాంపోజిషన్ చేస్తే F వస్తది. సో these are the results in function. Right. Right. Next is this is third result. Composition map is associative. That means this is my A, this is my B, this is my C. If is a function from A to B, G is a function from B to C. This is my H. Suppose this is D. H is a function from C to D. In fact, composition is well defined. So H circle, G circle F is equals to H circle G circle F. This is true for any three functions which are suitable function in such a way that whose composition is well defined. So H circle G circle F is equals to H circle G circle F. So this is true for any three functions provided composition is meaningful. Right? Composition map may not be commutative. Example, commutative means in general this cannot be, in general this may not be true. So can you give such an example? Can you give such an example? This is my A, this is my B, this is my C, this is my F, this is my G. So F circle G, suppose you take A, B, 1, 2, 3, or else you can take this A, B, C. So D, E, F. So this is what actually this. You can take this. You can take this. Right? What is G circle F of A? That means what? G of F of A. That means what? G of F of A. Mistem. I don't know whether it works or not. Me తీసుకొని చూస్తే తెలుస్తుంది. So what is F of A? F of A is nothing but what? 1. Therefore G of 1 is nothing but what? D. Right? What is G circle F of B? Means G of F of B. But what is F of B? 2. What is G of 2? E. So G circle F of C. That means G of F of C. That means what? G of F of C is nothing but what? 1. G of 1 is nothing but what? D. And look at F circle. What is my F circle? G. This is nothing but what? So does it exist, the F circle Z? Anybody? So this is my A, B, C. So this is my 1, 2. What is my F? This is my F. A goes to 1, B goes to 2, C goes to 1. This is my F. This is my G. What is my G here? So function from 1 to 2. Right, 1 to 2. What is my G? G is 1 to D. Sorry. What is my G function? What is my F function? My F function from A to B to C, 1, 2. What is my G function? So first you need to write the sets. Well defined the function. Well f circle g well defined the. This is my actually what g. You need to write g first. What is my g? 1 to d. Kada g and first. Need to mention for properly. First you need to write what I require. First of all, you need to write it. What I require first. You need, in order to define f circle g, first you need to write g. What is my g? 1 to and d. Yes or no? 1 to d. So 1 goes to d, 2 goes to e. What is my f? My f is what? See, this is not meaningful, right? So what you observe? G circle, f circle g may not exist. In fact, understand? Can you write f circle g? Can you write f circle g? G circle f is meaningful. G circle f is meaningful. Can you write f circle g? Yes or no? So therefore it's not possible. Therefore, what you observe, commutative composition of mappings may not be commutative. We can easily observe this. Of course, we can take any random example also. This is a 5 for finite sets. Right? Next is this also important property. Next property. Fifth one is, if you take f is a bijection function, f is 1 function from a to b is 1 g is a function from b to c is 1 so g circle f, yesterday I told you, if g circle f is from a to c is 1 that means composition of 1 function is 1 function. Composition of 1 function is 1. That means if f is a function from a to b, this is 1. This is a function from b to c is 1. So then this g circle of is 1. Right? So can you give converse? So converse may not be true in general. You can take the same example, I think, which works. So ఇక్కడ ఏంటి యాక్చువల్గా అంటే కాన్వర్స్ అంటే జీ సర్కిల్ ఆఫ్ 1 అయితే జీ అండ్ ఎఫ్ లో 1 అయితే అని క్వశ్చన్ కదా. f11 అయితే ఎస్టర్డే ఏం చెప్పాను కదా, కాన్వర్స్ f11 అవుతుంది కానీ g11 కాదు. సో g11 కాదు అంటే యాక్చువల్గా g11 ఎప్పుడు కాదు, దీంట్లో ఎక్కువ ఎలిమెంట్స్ ఉన్నప్పుడు కాదు. g ఎప్పుడు 11 కాదు. దిస్ ఇస్ మై యాక్చువల్లీ వాట్ g, దిస్ ఇస్ యాక్చువల్లీ వాట్ మై f. సో g లో మోర్ నెంబర్ ఆఫ్ ఎలిమెంట్స్ ఉన్నప్పుడు ప్రాబ్లం వస్తుంది. g సర్కిల్ f 11 అయింది అనుకోండి, f11 అవుతుంది, నెక్స్ట్ వస్తుంది రిజల్ట్ అదే. బట్ g మే నాట్ బి 1 ఫంక్షన్. g 1 కాదు అంటే మనం ఏమేం చేయాలి? వాట్ యు డు? ఫిక్స్ మోర్ నెంబర్ ఆఫ్ ఎలిమెంట్స్ ఇన్ కోడొమైన్. దిస్ abc, సపోజ్ యు టేక్ 1 2, సపోజ్ యు టేక్ ఇష్టం ఏదైనా ఒకటి తీసుకోండి, de సమ్ లేకపోతే 3 4. ఓకే, సో దిస్ ఇట్లా ఇచ్చేయండి. Okay, what is g circle of? G circle of 3 is equals to 3 goes to 1, 1 goes to a. G circle of 4 is equals to g circle of 4 is equals to g of f of 4. What is f of 4? 2. What is g of 2? b. So definitely distinct elements of a as distinct images. But the thing is g అంటూ g11 అయిద్దా? ఇక్కడ 11 అవుతుంది కదా, ఇక్కడ 11 అవుతుంది కదా. Yes or no? 11 g11 అవుతుంది as well as f కూడా 11 అవుతుంది, ప్రాబ్లం ఏం లేదు. బట్ ద థింగ్ ఈస్, ఇఫ్ యూ టేక్ దిస్ ఎగ్జాంపుల్, f 11 అవుతుంది, g11 కావద్దు. g11 కావద్దు అంటే ఏం చేయాలి? ఇదేంటి అయ్యే ఎగ్జాంపుల్, కాని ఎగ్జాంపుల్ ఏంటి? g11 కావద్దు అంటే డొమైన్ లో ఎక్కువ ఎలిమెంట్ తీసుకోండి. యూ కెన్ టేక్ దిస్ 1 2, ఇక్కడ మీ ఇష్టం ఏదైనా తీసుకోండి. దిస్ ఇస్ మై f, దిస్ ఇస్ మై g. సో క్లియర్ గా మీరు అబ్జర్వ్ చేస్తే, వాట్ ఈస్ g సర్కిల్ ఆఫ్ 3? 1. వాట్ ఈస్ g సర్కిల్ ఆఫ్ 4? g సర్కిల్ ఆఫ్ 4 ఏమైతే 4 goes to b, b goes to 2 అంటే డిస్టింక్ట్ ఎలిమెంట్స్ 3 కి 1 ఉంది, 4 కి 2 ఉంది. అంటే ఏంటి? G circle of is 1 ఫంక్షన్. థింగ్ ఈస్ G 1 అయిద్దా? A కి యాక్చువల్‌గా 1 ఇమేజ్ ఉంది, C కి యాక్చువల్‌గా 1 ఇమేజ్ ఉంది. A కి 1 ఉంది, C కి కూడా 1 ఉంది. బట్ థింగ్ ఈస్ A నాట్ ఈక్వల్స్ టు C. Therefore, what you observe? G is not 1 function. So converse may not be true. అంటే కావచ్చు కాకపోవచ్చు. ఇది అయిద్ది, ఇది కావట్లేదు. సో కాన్వర్స్ ఏంటి యాక్చువల్‌గా? సో దిస్ ఇస్ a property. If G circle f is from A to C is 1 function, no need to mention it. If the composition is 1 function, ఈచ్ ప్రాపర్టీ ఇస్ ఇంపార్టెంట్. చెప్పాను కదా, ఇవన్నీ ప్రాబ్లమ్స్ CSR గేట్లో వచ్చిన ప్రాబ్లమ్స్. ఓకే, దీన్ని బేస్డ్ చేసుకొని వెరీ వెరీ ఇంపార్టెంట్. సో F is 1 but G may not be 1. We have to give an example కదా. Similarly, onto composition of onto is onto. Onto functions is onto, right? That means F is a function from A to B is onto, G is a function from A to B to C is onto. Automatically G circle F is onto. This is onto, provided F and G are onto function. What about the converse? If G circle F is onto, does it mean that F and G are onto? So answer is G onto, but F may not be onto. So keep in mind, these are very very important properties. Yesterday చెప్పాను కదా, గేట్ ప్రాబ్లం CSR లో వచ్చింది, గేట్ లో వచ్చింది ప్రాబ్లం. సో కెన్ యూ గివ్ ఎగ్జాంపుల్? ఇదే ఎగ్జాంపుల్ పనిచేస్తుంది మనకి. ఎగ్జాంపుల్ చూస్తే ఎగ్జాంపుల్ లో F G circle F ఏంటి యాక్చువల్గా? అంటే ఫంక్షన్
దీనికంటే ముందు
ఈ ఎగ్జాంపుల్ చూడండి, జస్ట్ సరిపోద్ది అనుకుంటా. చూడండి ఒకసారి, G circle F చూడండి, ఇది యాక్చువల్గా బైజెక్షన్ అవుతుంది కాబట్టి ఆన్టు ఆటోమేటిక్గా అవుతుంది. ఈ ఎగ్జాంపుల్ తీసుకుంటే ఇది బైజెక్షన్ అయితే, ఎందుకంటే 3 goes to 1, 4 goes to 2. సో డిస్టింక్ట్ ఎలిమెంట్ కి డిస్టింక్ట్ ఇమేజెస్ ఉంది, అండ్ ఎవ్రీ ఎలిమెంట్ ఇన్ సి ఇట్ హస్ అ ప్రీ ఇమేజ్ అండర్ ద ఫంక్షన్ G circle F. ఆన్టు కూడా అయింది, బైజెక్షన్ అయితే. థింగ్ ఏంటంటే ఎఫ్ ఆన్టు అయిద్దా? మరి ఎఫ్ అంటే ఆన్టు అయిద్దా? సి ఖాళీగా ఉంది చూడండి, ఎఫ్ ఆన్టు అవుతుందా?
No, sir.
సో కాబట్టి కాదనమాట. సో కాన్వర్స్ మే నాట్ బి ట్రూ. ద సేమ్ ఎగ్జాంపుల్. సో G ఆన్టు అయింది, బట్ F ఆన్టు కావాల్సిన అవసరం లేదు కదా. ఇది కూడా ఇంపార్టెంట్ నోట్. సో ప్రాపర్టీ నెంబర్ దిస్ వాట్ ఈస్ ద ప్రాపర్టీ? యా, నెంబర్ ఏమి ఇస్తలేని జస్ట్ రాయండి. ఓకే, సో నెక్స్ట్ ఈస్, ఇది కూడా ఇంపార్టెంట్. ఇవన్నీ చాలా చాలా ఇంపార్టెంట్. యు టేక్ ఎనీ ఫంక్షన్ ఫ్రమ్ X to any function that you take. So this is my function, this is my A. You take any subset of X, then the following property is always true. You take any subset of X, A is always subset of inverse image of A. This is always true for any subset of X, any subset of domain. Right? In fact, this is a proper subset. You need to give a counter. This is notice. Note right as an example. It's a notice. So it's a proper subset. It may not be full. So can you give example? When I write an IIT JAM examination, this question asked in IIT JAM, this type of question. So converse may not be true. Can you give two sets? Can you give a function? And can you give a set in such a way that A not equals to inverse image of F of A? Can you give such a function? So నేను ఇస్తాను, యాక్చువల్గా ఎట్లా ఇస్తానంటే F is a function from R to R defined by F of X is equals to X square ఇస్తాను. చూద్దాం ఏమైందో. I don't know whether it works or not. కావచ్చు కాకపోవచ్చు, రైట్? చూద్దాం వాట్ విల్ హ్యాపెన్. నేను ఏమి ఇస్తానంటే యాక్చువల్గా 0 to 2 ఇస్తాను. What is my A? My A is 0 to 2. This is my 0, this is my 2. This is my graph y equals to X square. So question is, what is the image of A? Image of a function definition is set of all elements of the form fx such that x belongs to a. That means what is my fx? X square. What is my fx? X square. What is my x belongs to a? X belongs to a. What is a? 0 to 2. That means set of all x square such that 0 less than or equals to x less than or equals to 2. So what is this when you simplify this? See, this is my x equals to 0. When you draw a line, it meets the curve at 0 only. So this is my actually what? 2. So what is the image? What is the image? 4. Therefore, what you get? 0 to 4. 0 to 4. Next, what I require? I require to find if inverse image of f of a. Inverse image of f of a. What is inverse image of a set definition? Inverse image of a set definition is set of all elements in a. This is my function. You take any subset which is in A. Inverse image of a set is defined by set of all pre-images, set of all elements in A such that whose image belongs to E. Set of all elements in X in such a way that whose image belongs to E. So here, f inverse of what is my f of A? My f of A is 0 to 4. So what is inverse image? Set of all elements in a domain such that whose image belongs to close 0, 4. That means set of all real numbers such that what is my f of x? X square belongs to closed interval 0 to 4. That means set of all real numbers such that 0 less than or equals to x less than or equals to 4. That means what is this actually? This is y equals to x square. So x square values lies between 0 to 4. This is 0. X square value lies between 0 to 4. We are looking for a pre-images. What are the pre-images? What is the pre-image of 4? It intersects +2 and -2. So what is my pre-image? -2, 2. Question is it equals to A? Actually, what is my A? My A is 0 to 2. Are they equal?
No.
No. So therefore, what you observe is the inverse image of f of A need not be equals to A. Understand? Need not be equals to A, but it is a proper subset. A is a proper subset of this. Of course, it can be equal by taking another condition. If f is one function, these are equal. This is true for what? You take any subset of x. This is another notice. So in general, this is a proper subset. But the thing is, when you take one function, this is true. When you take one function, it is true. You can simply prove it, but I don't want to prove all the results. I don't want the theorem. I don't want to write as a theorem and prove it. Okay, this is also important. Next is when you take any function from x to y, when you take any element in any member which is in codomain, for codomain you can take the notation as B. What is my codomain? Take the notation B. So this means this is my function from x to y. You take any subset which is in y. So automatically inverse image of inverse image of B is always subset of B. This is always true. You take any function. So image of inverse image of B is always subset of B. This is true for any subset of B, any subset of Y. This is also very, very important property. In fact, it's a proper subset. We can easily check it by taking we take an element here. You need to show that. See, easily prove it. You could take an element this then automatically this is an element of this. Thing is, why it is proper? That is important. So can you give example? So why it is proper? Can you give example? Same thing. I'm going to take a function from R to R. Onto on the end. Onto is simply true. It's onto an example of this circle. Suppose you take this, A is equals to same thing. -2 to do this quantity. Right? What is the inverse image of B? What is inverse image of A? set of all elements in a domain such that whose image belongs to A. That means set of all real numbers. What is the f of x? X square belongs to -2 to 2. That means set of all real numbers such that -2 less than or equals to x less than or x square less than or equals to 2. But the thing is, x square cannot be negative. Therefore, set of all real numbers such that 0 less than or equals to x square less than 2. But we are looking for x solutions. So this is my graph actually. This is 0 to 2. You are looking for 3 images. What is this? -√2 plus √2. This is inverse image of A. But what I'm interested in image of inverse image of A. What is this? What is this? Anybody? What is this? This is nothing but f of what is inverse image? -√2 √2.
Why you are taking A, sir?
ఏ తీసుకుంటే నోటేషన్ నేను ఏ ఇచ్చాను, మీరు బి తీసుకుంటే బి ఇక్కడ.
It will be confusing, no?
యా ఓకే, మీరు బి తీసుకోండి. ఓకే మిస్టర్. ఓకే, నౌ ఇట్స్ బి. ఓకే, నౌ ఇట్స్ ఓకే. సో therefore f of x such that x belongs to -√2 √2. What is my f of x? X square such that x lies between -√2 to √2. So question is, what are the images of what is the image of this interval under the function -√2 to √2? అంతే కదా, దీని ఇంటర్వెల్ యొక్క ఇమేజ్ ఏంటి? జస్ట్ వాట్ యు డు, జస్ట్ డ్రా ఎ లైన్ parallel to y axis. It meets exactly at 2. Yes or no? Therefore 0 to 2. Question is it equals to -√2 √2 -2 to what is my b? My b is -2 to +2. Is it equals to b? No. This is 0 to 2. This is equals to -√2 to -2 to 2. Therefore they cannot be equal. So in general it is a proper subset. That is simply observe that by taking this example. But when you say that this is true, this is a proper subset may be equal.
F is onto. F is onto
function. So these are very, very important. If it is an onto function, if and only if image of inverse image of b is equals to b, if you take any subset of y. This is also very, very strong example, right? Next is, f is a function from a to b, y is a function. We take any a comma b are which are subsets of x domain. So first one, image of a and b is equals to union of images. This is always true. Image of intersection is nothing but is contained in intersection of images. So exercise ఏంటంటే మీకు ఇది ప్రాపర్ సబ్సెట్ అవుతుంది. ఒక ఎగ్జాంపుల్ ఇవ్వండి. ఓకే, వై ఇది ఎందుకు ప్రాపర్ సబ్సెట్ అవుతుంది ఒక ఎగ్జాంపుల్ ఇవ్వండి. సో దిస్ ఇస్ అన్ ఎక్సర్సైజ్, టుడే ఎక్సర్సైజ్. జనరల్ ఇది ప్రాపర్ సబ్సెట్ అవుతుంది. ఎందుకు అవుతుంది అనేది మీ యూనిట్ టు గివ్ ఏ అండ్ బి అండ్ యూనిట్ టు గివ్ ఏ ఫంక్షన్ ఫ్రమ్ x to y. ఫంక్షన్ ఇవ్వండి, ఏబీలు ఇవ్వండి, ఎందుకు ప్రాపర్ సబ్సెట్ అవుతుందో ప్రూవ్ చేయండి. ఓకే, దిస్ ఆల్సో వెరీ, వెరీ ఇంపార్టెంట్ ప్రాబ్లం. ఇది నేను ఎస్సీయూ సెంట్రల్ యూనివర్సిటీ అప్లై చేసినప్పుడు ఈ క్వశ్చన్ వచ్చిందమ్మా. సో ఇంతకుముందు ఎస్సీలో నేను ఎంఎస్సీ ఎంట్రన్స్ ఎగ్జామ్ రాసినప్పుడు వచ్చింది. సిమిలర్గా ఇట్ ఈస్ ఎ ఫంక్షన్ ఫ్రమ్ x to y, is a function when you take a and b are subsets of y codomain. So automatically inverse image of a and b is always same as saying that union of inverse images. And inverse image of intersection is nothing but intersection of inverse images. Of course this result is true for arbitrary union also, arbitrary intersection. You are taking actually two members. Of course this result is true for any arbitrary unions. No, inverse image of union is nothing but union of inverse images. What is my alpha? You take any alpha which is a subset of domain, codomain, sorry. Subset of codomain. This is true for any collection, right? You take any inverse image of b alpha ఓకే, మీకు ప్రాబ్లం అనిపిస్తే ఇక్కడ నోటేషన్ బి ఆల్ఫా తీసుకోండి. బి అంటే కోడోమైన్ అని తీసుకున్నారు కదా. ఓకే, బి ఆల్ఫా. వాట్ ఈస్ దట్? యూనియన్ ఆఫ్ ఇన్వర్స్ ఇమేజ్ ఆఫ్. సో ఇన్వర్స్ ఇమేజ్ అనేది యాక్చువల్గా కోడోమైన్కే పనిచేస్తుంది, డొమైన్కి పనిచేయదు. సో వాట్ ఈస్ దట్? ఇంటర్సెక్షన్. బి తీసుకోండి, బి కోడోమైన్ కదా. ఓకే, బి. సో దిస్ ఇస్ నథింగ్ బట్ వన్ inverse image of B alpha. Okay, this is true for any collection that you take any subset of Y. This is also very, very important property. Right. Next is that equivalent sets and countability. I'm going to start.